Hey everyone. So today we're going to be proving that ZP, where P is prime, is a field. So we know that for a ring to be a field, the ring must be commutative, unital, it must have no zero divisors, and every non-zero element must have a multiplicative inverse. So let's start out by listing the elements of ZP. So here are the elements of ZP, and every one of those conditions for a ring to form a field is obvious except for the multiplicative inverse. So we're going to try to prove that every non-zero element of ZP has a multiplicative inverse. So let M be an element of ZP. Now let's multiply every one of the elements of ZP by M. Now, we're going to assume that M has no multiplicative inverse in Z. Okay, so that means, because M has no multiplicative inverse, that none of these can be equal to 1. So 0M, 1M, 2M, none of them are equal to 1. And by the pigeonhole principle, that means that two of these have to be equal. So let IM and we're just going to say IM and JM are equal in the field. So IM is congruent to JM mod P. So we can rewrite this as I minus J times M is congruent to 0 mod P. Okay, from here, let's just say I is greater than J for simplification. And now we know that if I is greater than J, that means that 0 is less than I minus J. And I minus J, because IM and JM are elements of ZP times M, we know that I minus J has to be less than P. Okay, and from here, we know that the only divisors of P are P and 1. So that means that I minus J can't make this expression true, and the only way for this to be true is for M to be equal to 0. So here, M must be equal to 0. And if M equals 0, that means the only element here that doesn't have a multiplicative inverse is 0, which satisfies the conditions for the field. Therefore, ZP does form a field. Now we're going to try to prove that ZK, where K is composite, does not form a field, showing that ZP is the only way we can form a field with Z mod some number. Okay, so we're going to say ZK, and then where K equals A times B does not form a field. Okay, so if K equals A times B, that means that A times B is congruent to 0 mod K. And if A times B is congruent to 0 mod K, that means that AB is a zero divisor in ZK. And that's that's a contradiction, because that is not allowed in a field, showing that if K is composite, ZK does not form a field. Thank you guys for watching, and subscribe and comment if you have any questions.